Today I'll be showing you how to conduct a Poisson and a negative binomial regression in SPSS using the generalized linear model component of the program. The SPSS package I'll be demonstrating with today is 15, so later versions of SPSS have slightly different formats when you go into the generalized linear model component, but it's similar enough that I think this will be helpful. So today, just to let you know a little bit of background about the data we'll be using, we are using the results of an online survey used with college students at a university in the northwest of the U.S. And there are 837 college students who participated in this baseline or initial data collection. So this will be a cross-sectional analysis today. And the DV, or the dependent variable, the outcome variable, is baseline peak drinks. So that means within the last 30 days, participants needed to think about the day they consumed the most alcohol, and they just counted up the number of drinks and estimated the number of drinks from that particular drinking occasion. And so that will serve as our outcome variable, and our independent variables, or our predictors, are going to be gender, so male or female, attitudes about drinking, and that is the summary score, the mean summary score that we've centered from the global attitude scale. And we have then a gender by attitudes interaction. So that's the background for the model we'll be using today. And so going into SPSS and getting right to the data, you'll see here we have a typical SPSS data view up, and what we need to do is our first step is go to the Analyze button in the toolbar, and we're going to choose Generalized Linear Models. Now this is very different from General Linear Model, which is a set of analyses that's based on the Gaussian distribution, and the Generalized Linear Models are actually generalized from the general linear model, but they are regression analyses in this particular case for alternate distributional assumptions that go beyond the normal or Gaussian distribution. Within this, we're going to choose the generalized linear models. Generalized estimating equations is also for alternate distributions, but it is for clustered data or longitudinal data, panel data. So we're going to go ahead and choose Generalized Linear Models, and what you'll see here is a series of tabs. You can kind of go through this step by step. Our first tab is the response variable, and we're going to just enter in our dependent variable under dependent variable. So not a difficult first step. We'll put baseline peak drinks in here. Now if you had a binary response where you'd be probably using some kind of binomial model, so either a logistic regression or probit regression or whatnot, or maybe a more general binomial model, you would go ahead and click that here and specify further. We are, of course, conducting today a Poisson regression, so we can skip that and leave that unchecked and just go down and select Poisson for our distribution. And I didn't really talk about why Poisson regression and negative binomial regression would be sort of the first stop for me in terms of considering what kind of alternate distribution I would want to select. And the reason why is because baseline peak drinks, as you can probably imagine, is a count variable, but it's also positively skewed. So this means the tail kind of dwindles off into the positive direction. So that usually means that we have a lot of people, especially college students who may be less experienced drinkers, kind of piled up at 0 and 1 and 2 drinks, whereas you have a few outliers that of course are going to compose this tail that kind of moves out into the positive direction. And because of that, both Poisson and negative binomial distributions that are similar to that kind of a skewed distribution are pretty ideal. Now we're starting with the Poisson, and the Poisson is a little bit difficult because it's actually going to assume that the mean equals the variance, and we're going to find that that is probably not as true for this particular variable. But it's good exercise to kind of look at how these different models measure up for a particular variable. So at this point we're going to go ahead and choose the log link, and that's going to make the resulting exponentiated coefficients that we'll get as output a little bit more interpretable. So you want to go ahead and choose the log link for Poisson regression. And then we're going to go ahead and go to the predictors tab. Now here we can specify either factors or covariates, and these are going to be the independent variables in our model or the predictors. Now factors are for categorical variables only. So any variable you put in there, even if it is a continuous variable, it will be treated categorically. So you want to be sure you're putting the right variables in there. So our categorical variable here is gender. And then we're going to go ahead and put our covariate in here, which is centered global attitudes about alcohol. And what you can do in terms of options here is if you'd like to specify which category order you'd like to have for the factors, you can. And not just, for example, birth sex here is coded as 0 or 1, where 0 is for males in the study and 1 is for females. So you can either have it print out results that focus on males as the reference or females as the reference point, and you can choose that accordingly. So we're going to go ahead and use the descending order. So we start with women, and we can reverse that later as well to get the incident rate ratios for both focal groups. So here, down here, you can see there's a place for an offset. Now this isn't necessary really for baseline peak drinks because we don't really have a set number of trials, quote unquote trials, in which you could have a certain number of successes. Now this would be a little bit different if, say, we had people fill out a drinking diary for 30 days. So they would have an option of having up to 30 days that they could have talked about having drank something. And that gives you kind of an upper bound. So if you have that, you can use the offset to control for the fact that perhaps different numbers of people filled out different numbers of days. And this can happen sometimes, like if someone is filling out a diary and accidentally skips a week because they forgot to pick up their diary, you can control for the fact that instead of 30 days of data, they only gave you, for example, 23 days of data. So you can control for the fact that they had different numbers of trials in which they could have successes. Trials being days of data on which they could have reported drinking. Now this isn't really the case for our particular dependent variable, so we're going to go ahead and move on to model. And what we can do in SPSS is we can either select the variables we've chosen as our factors and covariates and move them over, and then also talk about making an interaction here out of the two and moving that over. Or you can go ahead and select both variables and then specify factorial. Factorial will go ahead and include the main effects and any other interaction effects from top down. So we're going to go ahead and do that for this particular variable, and it tells us we have 3 effects in our model. Most of the time you're going to want to go ahead and include the intercept in your model. There are a few cases where this might not be how you want to do things, but typically you want to go ahead and include the intercept.